Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at speed. You've probably heard of speed before. It's the way that we quantify, so put into numbers, how quickly something or someone is traveling. So speed is a rate. It is written as distance per time. You'll usually see it written as kilometers per hour or meters per second. When people say speed, they're really talking about average speed. So average speed tells us how quickly we were going. So how do we actually calculate that? Well, this triangle is supposed to help you remember how to perform calculations involving speed. This means speed, distance, and time. If you want to calculate speed, you kind of cover up this part of the diagram. You're left with d over t. Speed equals distance over time. If you want to find d, the distance, you sort of cover that up and you're left with st. So remember, in algebra, if we don't write an operation, it's time. Distance equals speed times time. And similarly, if I want to find t, I cover it up and I'm left with d over s. Time equals distance over speed. We are going to perform calculations to find speed, distance, or time. So just so we note that speed is normally written in kilometers per hour or meters per second, there is a very easy way to convert between the two. If you want to go from kilometers per hour to meters per second, you divide by 3.6. And the opposite is true. If you want to go from meters per second to kilometers per hour, you times by 3.6. So let's just start with an easy example. A sprinter can run 200 meters in 20 seconds. So it's sort of hard to compare that sprinter. Is that sprinter going, say, as fast as a car? Well, that's hard to know. What we do is we write the speed as a rate, kilometers per hour or meters per second, that allows for easy comparison. So if I want to find the speed of this sprinter, it is just the distance traveled over the time. So the speed is 200 meters distance over time, 20 seconds. So 200 divided by 20 is just 10. And the units here is meters per second. So what that means is that on average, because this is average speed, the sprinter is traveling 10 meters per second. Read this as per. Okay, so is that as fast as a car? Well, that's hard to tell because cars, their speed is usually measured in kilometers per hour. So if I want to convert this to kilometers per hour, consistent with the diagram above, we go from meters per second to kilometers per hour by timesing 3.6. So 10 times 3.6 gives us 36. That sprinter is traveling at a speed of 36 kilometers per hour. So you can see that that's not quite as fast as most cars would be driving on the road. That allows us to easily compare the speed of this sprinter with other known speeds. So this 36 kilometers per hour, as I said, is an average. What it's saying is if the sprinter kept up this same rate of speed for a 1 whole hour, they would travel 36 kilometers. Now, obviously, no one's that fast they could keep it up for a whole hour. But again, it's just an average. We take the average speed here so we can compare how quickly things are moving. All right, let's now look at some other examples. So suppose it takes me 20 minutes to cycle 14 kilometers. We're going to calculate how far I could cycle in 90 minutes. So the first thing I do in a question like this is to calculate the speed. How quickly am I cycling? 14 kilometers goes on top because speed is distance over time. Distance on top, time on the bottom. So if I do 14 divided by 20, I get 0.7, and it's kilometers per minute. Kilometers per minute because we had kilometers on the top, minutes on the bottom. So this is my speed. Now this is asking how far I could travel. It's asking for distance. As we saw on the previous slide, distance equals speed times time. So what I do is I multiply the speed. I'm just going to use the number 0.7 times the time. So when you're doing this, you have to be careful that the units are the same. Because this is minutes and this is kilometers per minute, I know my answer is going to be right. If this was kilometers per hour, this would need to be written in hours. If this was meters per second, this would need to be in seconds. Units have to match up. So kilometers per minute times minute gives me the number of kilometers. 0.7 times 60, can use your calculator, is 63. At that same rate, I could travel 63 kilometers. So this question says, how long would it take me to cycle 280 kilometers to Sydney? How long? It is asking me for the time. As we saw on the previous slide, time equals distance over speed. So here it's 280 kilometers, that's the distance, and the speed is 0.7 kilometers per minute. So if I do 280 divide 0.7, I actually get 400. So because it was kilometers per minute, this answer is in minutes. It would take me 400 minutes to cycle to Sydney. If I want to know how many hours that is, divide by 60, you get 6.6 recurring. It's 6.6 recurring hours. This is 2/3 of an hour. So 2/3 of an hour is 40 minutes. It's 6 hours and 40 minutes. That's how long it would take me to cycle to Sydney if my average speed was this 0.7 kilometers per minute, which is 42 kilometers per hour. So just note here that, again, this is an average speed. This is saying if I kept up the average speed, it would take me this long. I probably couldn't, in fact, I'm sure I couldn't, keep up this speed for 6 hours straight. Again, it's just an average. All right, let's look at a harder question. So I live 6 kilometers from school. I run to school at 9 kilometers per hour, then walk home at 3 kilometers per hour. I'm going to calculate my average speed in both kilometers per hour and meters per second. So this is a tricky question because most people, when they see it, they would think, okay, halfway between 3 and 9 is 6 kilometers per hour. That must be my average speed. That's actually not the answer. The reason is that I would spend substantially more time walking than I did running. So my speed's actually going to be closer to 3 kilometers per hour than it is to 9 kilometers per hour. Okay, so if the answer's not 6, what exactly is it? Well, we can just use what we learned on the first slide. Speed is always distance over time. Now we know the distance here. The distance is going to be 6 kilometers there, 6 kilometers running, and 6 kilometers back, 6 kilometers walking. It is going to be 12 kilometers in total. The thing we don't know is the time. So let's go and figure out the time. We need to find how long it would take me to run to school and how long it would take me to walk home from school. So let's do that. Let's say I'm running. So how long would it take me to run 6 kilometers if this is my speed? Well, we know that the time taken is distance over speed. So the time taken is 6 kilometers. The speed is 9 kilometers per hour. So 6 divided by 9 is 2/3. Because it was hours on the bottom here, that's my time in hours. So it's not 2/3 of a minute, it's 2/3 of an hour. If you want that in minutes times by 60, we have 40 minutes. It would take me 40 minutes to run to school. What about walking? The time taken walking is distance over speed. It is 6 kilometers home divided by the speed, which is 3 kilometers per hour. This is a nice, easy calculation. 6 divided 3 is 2 because it was hours on the bottom. That's my answer in hours. It's not 2 minutes or 2 seconds, it's 2 hours. So Just so we know, 2 hours is 120 minutes. Okay, so what then is my average speed? So, as I said, the total distance is 12 kilometers. Now, the time taken is 40 plus 120. It's 160 minutes. But the question asks for speed in kilometers per hour. Well, I've got the kilometers part, but not the hours part. So 160 minutes. How many hours is that? If you want to know, divide by 60. If you divide by 60, you get 2.6 recurring. It's 2 2/3 of an hour. So putting that in our calculator, we get 4.5 because kilometers it's kilometers per hour. That's my average speed in kilometers per hour. To find the speed in meters per second, we simply divide 3.6. The answer we get is 1.25 meters per second. So these are equivalent speeds. If you go at 4.5 kilometers per hour and 1.25 meters per second, you are traveling at the exact same speed. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.